This is going to be about my favorite unit in grade 9 math, and this is about solving for unknown in an equation. The reason why I love this unit so much, I remember doing this when I was in grade 9, and I enjoyed it so much because I can always verify and double check my answer to see if I actually did it right, because that's what an equation is. An equation basically is something. It has to equal to something. It's like a formula. It's like instruction book that tells you what is equal to what, and you can't really change it. So you might have heard that if you do something to one side of the equation, you have to do it to the other side. There's a reason for that. So here's a scenario. If we were to have, say, something like go to the market and you have 2 oranges and it's $6. Well, and then I'm gonna ask you, well, how much is 1 orange? And I'm sure that you can pretty much guess or even calculate in your head immediately that, well, 1 orange is gonna cost $3. So why was it so easy to sort of see in a picture? And once when you see like 2x is equal to 6, why is it so much more difficult to do that? To start you off, after that example, there's a couple of things that you have to know for solving for an unknown for an equation. And here are the couple of things. Your goal of solving equation is that you want to get all the variables onto one side and all the numbers onto the other. So that's sort of going to be your goal in solving for equation. The next one is that you want to solve for just one variable. So what that means is that you're not trying to calculate how much something is for 2 oranges or 5 or 10 or 0.1. You want to solve for how much is just for 1 orange or 1 x or 1 y, and that's the goal. So you want to have all the variables on one side, you want to solve for just one, and the last thing, your objective of solving for a unknown is that you want to solve for a positive single variable. So in the example with the oranges, you don't want to solve for a negative orange, right? You want to solve for what a positive 1 orange is, or how much that is. So that's your sort of starting point in solving for an unknown. So let's see a couple examples and how we can establish this. Here's going to be the first example about solving equations. And if you're a student from my class, you're going to know that I like to teach this at different levels, as in like leveling up or increasing of difficulty. I'm going to show you that, and I'm also going to show you just how it is to solve an equation. So the first example we're going to have is, say you have like your 2 oranges is equal to 6, right? This is a pretty straightforward example, and a lot of people sort of get intimidated just because they see the algebra, the x here. But this is just the same as if we were to have, you know, your 2 oranges, that's our initial example, is equal to, we have $6, 1 2 3 4 5 6. So you can see that if I were to sort of make this into 2 groups, or if I were to find out and calculate how much is just 1 orange, you would divide this by 2, right? You would divide this by 2 because by dividing by 2, this would give you 1 orange, and by dividing by 2 on this left side, we have to do it to the other side because this is an equation. So you can tell that 1 orange is equal to $3. So in the algebraic expression, I'm just going to divide this by 2, divide this by 2. The 2's would cancel, and an x is equal to 3. Pretty straightforward. And you can see that this is just going to be, remember our objectives is that we need to solve for the variable, we need to solve for single one variable, and we have to solve for a positive variable. So this is all we did. We solved for the variable, which is on the left side. We solved for a single one. This is a single one, and this is a positive one. That's our goal. If we were to make this into a more complicated example, let's just say 21 is equal to 3y. You notice that this y is on the right side of the equation, but it doesn't matter because this is the equation. This y or variable can be on the right side or the left side. It doesn't matter. As long as you understand the step that what you do to one side, you have to do to the other, because you have to make them sort of fair. So if I were to do this, this is just basically saying that you have 21 dots. Oh, there's going to be a lot of dots to draw, but here your 21 dots. So I think this is at 20 and 21, and this is going to be equal to 3y. So let's just say 3 elephants. I don't know how cheap this is, but this is an elephant. So for this elephant, if we were to buy 3, I guess, of these toy elephants, or maybe realistic elephants, they're going to be equal to $21 to 21 dots. So remember, our goal is that we need to get all the variables, which this is right here on one side, and we need to get a single variable. So this is our next objective, because right now we have 3. I need to just have 1, and in order to get to just 1, I'm going to divide by 3, because 3 elephants divided by 3 would be just 1 elephant. So if I do it to that side, I'm going to do it to this side. So this is going to be 7 is equal to just 1 elephant. So what would that look like algebraically, right? So then notice that I'm going to divide this, or this has 3y, I need 1y, so I'm going to divide this side by 3, divide this by 3. 21 divided by 3 is 7, is equal to 3's cancel out, 3 divided by 3 is 1, this is equals to y. So it doesn't matter where you start off, the y's can be on the right side or the left side or x or whatever, as long as you're dividing and just trying to get one single variable. So another example is, oh, my background switch, but what if we have like a negative number? So negative 4m is equal to, let's say, negative 12. So this one I can't really draw a negative 4m. I guess you can use algebra tiles and just kind of leave them blank. But right now, remember, our objective is that I need to get one single variable. Right now I don't, because I have negative 4 of them, and I need to have a positive single variable. So that's my last objective. So let's just get to one variable first. I can divide this by 4. This will make it negative m is equal to negative 3, because this makes it 1 negative m. And our last objective is to make it positive. So in order to make it positive, negative divided by negative is a positive. So I'm going to divide this by negative 1, m is equal to 3, because negative and negative will cancel the negatives, and that's my final answer. So to recap, this is a pretty straightforward step. You just wanted to have one single variable and a positive one, because once you understand that, the next several steps, or however difficult it is, it's actually not that bad. Okay, so let me stop it there. Okay, so after the first example, this is going to be a second example with a slight twist. So this is sort of the next level of our solving for equation. So remember last time that we had 2 oranges, and this was equal to $6. So 1, 2, 3, 4, 5, 6. Okay. Now the little twist that we're going to add here is that, well, instead of just having 2 oranges, we're going to have 2 oranges and $4. Let's try that. So we're going to have 2 oranges and $4. That in total is equal to $6. So that looks sort of weird. It's like, well, how do I solve for 1 orange? Well, that's the beauty of solving equations, because it allows you to solve for just 1 using equation form. So if I were to write this out algebraically, we're going to say that an orange is an unknown, and we're going to use a letter to represent this, and let's just say orange is x. And since we have 2 oranges on this side, we're going to say that we have 2x. Right? And remember, just to remember, I caution you, this 2x means it's 2 multiplied by x. It's not 2 plus x, it's 2x's, 2 times x. And then I have and since we have 4, we're going to say plus 4. That's my dollars. And then my equal sign is going to be 6. So that's what it looks like. This thing right here, this scenario, 2 oranges and $4 is equal to $6. If I were to change this into the algebra form, that's what it's going to look like. So remember, what we talked about before is that our objective of solving equations is that we want to solve for 1 single variable. So right now we can't do it automatically, because we have this $4 that's with the oranges, or the x. So the only thing that we can do is sort of move things around in the equation. Remember, this is an equation, so the left side and the right side the steps must be the same. Because if we were to say that, if we were to take this, what if I just wanted to say, okay, here, some guy's going to come in and say, I'm going to add $6 to this side of the equation. Well, is that fair to the sort of the equation? Like, is that equal? No, because you just added 6 things to the right side without doing anything to the left side. So that's not a possible step. So to make that sort of fair is that, well, if you're going to add 6 here, then I'm going to add 6 on the left side. Then that would make sense because that's what an equation is. But is that really solving how much is 1 orange? So to sort of recap on that, the purpose now is to look at this. Where is my variable? My variable is my x right here. Do I have anything sort of with my variable? Yeah, I have a 2 in front of it, so I have 2 variables, and I have a 4. And then that's the whole total of that is equal to 6. So the first thing is that I can't get rid of this 2 automatically because I have this plus 4 tagged along. So what I need to do is get rid of this 4. So since this is an equation, I need to, in order to get rid of something, I need to sort of do the opposite, right? Because right now I have a plus 4, so in order to get rid of it on this side, I have to subtract 4. But then, hey, wait a minute. If you do it on the left side, that's not fair because that means that you just took away $4 on the left side. How is that equal or fair? So then, to make that fair, I'm going to take away 4 on the right side. So plus 4 is going to equal to 0, so that's going to be gone. 6 subtract 4 is 2. Remember, this is subtract, that's why I have a subtraction sign. My equal sign stays the same. My 2x stays the same because I haven't done anything to it. So 2x is equal to 2. Now you can see that this is back into 2 oranges is equal to $2. So basically I need to solve for one single one. So I'm going to divide by 2 and divide by 2 both sides. X is equal to 1. So that's it. There's not much to it. You just have to make sure all your x's are on one side. So here's another example. Let's just say 5x minus 3 is equal to 18. So since this is going to be 5x, like say 5 oranges, subtract 3, take away $3 is equal to $18. I have my variable. I'm going to circle my variable. Is my variable with something else? Yeah, you have 5 of them, and also you have subtract 3 with it. So right now it's not by itself, so I can't just divide by 5. So in order to do that, I need to get rid of this negative 3. So in order to get rid of this negative 3, I need to do the opposite. So I'm going to add 3 on the left side, and I'm going to draw a line just to indicate I'm adding a 3. And if I'm adding a 3 on this side, I need to make it fair, add 3 on the right side. So this will cancel. 5x is equal to 18 plus 3 is 21. Now I have 5x by itself. Remember, the goal of solving an equation is that you want 1 and you want a 1 positive 1. So I'm going to divide by 5 on this side, divide by 5 on this side, and then that's x is equal to 21 over 5. I'm just going to leave this in a fraction. So is my x positive? Yeah. Is it single? Yeah. Is it by itself? Yeah. So that's my goal, and that's the first one. So this is the second level. It's a little bit more complicated because you have an extra number, but tune into the next one where you have a number on, you have a variable on both sides, and I can tell you what to do because it actually starts to make sense after this. Okay, so I'll see you in the next video. From our last example, we're going to change it up and add a little bit more. So we can say that we have my original one with 2 oranges, and remember this was originally equal to 6. But now we're going to switch it up. We're going to say that instead of just $6, we're going to say that it's going to equal, or 6 and, let's say, 4 more oranges on the right side. Now this looks sort of confusing because I have oranges on the left side, oranges on the right side, and then 6. How do I make this into algebraic expression? Well, remember, these ones we're going to use x to represent them. So we're going to say that we're going to use 2x is equal to 6 plus 1, 2, 3, and 4. So that's equal to 4x. So remember, our objective is that we want to get all our variables onto one side. Right now it's not. You can clearly see that there are 2 oranges on this side and 4 oranges on this side. And we can't just start to divide and subtract and all that stuff. So what do? Well, we need to get all the oranges on one side. And remember, this is an equation. So whatever you do on one side, you have to do it to the other side. So which side should we pick? It doesn't matter. So I'm going to pick, let's say, get rid of these 4 oranges. So get rid of these. Get rid of these. So how do I get rid of 4 oranges on the right side? Well, remember, you do the opposite. I subtract them. So I'm going to subtract 4x. And what I do to the right side, I do it to the left side, subtract 4x. And draw a line to represent my next step. 4, negative 4, this cancels out to 0. My 6 is still here, and my equal sign is still here. That's my next step. Now, this is 2 subtract 4. Remember, 2 subtract 4, that's going to be negative 2x. And then now, here's level 1, but then remember, my objective is that I want a single one, and I need a positive single one. Right now, I have negative 2. So I can divide this by 2, or I can just combine the two steps and divide this by negative 2 to both sides. The negative 2 and negative 2 will cancel. Negative with negative will cancel into a positive. 2 with 2 will cancel to 1. X stays because I didn't divide x by x, so x will stay. This is equal to 6 divided by negative 2 is negative 3. Is my x by itself? Yeah. Is it positive? Yeah. And that's all I have to do. So that's really why we have to move the x's onto one side and the numbers onto the other. So what if we were to just step this up a little bit and add a little bit more? So remember, we had 2 oranges is equal to 6, and then we have 4 oranges on, or I think I said 4 oranges earlier. So instead of that, well, we're going to have numbers on one side. We're going to have negative, let's say 12. Now we have oranges and numbers on both sides. Well, what do? Right, this looks confusing. Remember, the objective here is that you want to get all your x's or your oranges on one side of the equation, and you have to do that moving around by doing the opposite. So if I were to change this into my algebra, 2x subtract 12 is equal to 6 plus 4x. Bam! So now I have this equation. So it looks confusing, but I'm just going to circle my variables so then you can tell where they're at. And does it matter which side I'm going to move these x's to? No, because it's an equation. So I can move it to the left side or the right side. It doesn't matter. Remember, the objective here is that you want to get all the variables on one side, collect the like terms. So I'm just going to choose and move the x's to the left, and this is my 4x. I'm going to go subtract 4x on one side, subtract 4x on the other side. Notice it's like a mirror image. They all have to be the same. Plus 4, negative 4, cancels out to 0. That's what I want because I want to get rid of them. This 6 is here, so this is going to be plus 6 is equal to 2x minus 4 is 2 minus 4 is negative 2x. But wait a minute, I have this negative 12 now. So this is my another step. So remember, this is similar to my last example in level 2. You have your variable with a number. So I can't just divide by negative 2 just yet because I have negative 12. So let's move this to the other side, and by moving it, I need to do the opposite. So this is a negative, the opposite is a positive. So plus 12 on both sides. This is going to cancel to 0. Equal 6 plus 12 is 18 minus 2x. Remember my objective, I need a single positive one. Right now I have 2 negative ones. So I'm going to divide by the number in front and along with the sign. So a negative and a negative will cancel to a positive. Oh, I'm running out of room here. So that's going to be a positive. 2 divided by 2 is 1. And then x is equal to 18 divided by negative 2. Positive divided by negative is negative. 18 divided by 2 is negative 9. There you go. So that's your answer. And you can always double check this by substituting this number back in wherever you see the x. So if we were to use this example, you would have 2x minus 12 is equal to, I think it's 6 plus 4x. What we solved was negative 9, right? That was our answer right here. So in order to double check this, this is actually the best part because you can always guarantee that you got your answers right on the test. So you're going to, wherever you see an x, because this is saying that x is equal to negative 9, wherever you see x here, there's x, you're going to substitute this negative 9 in there. So 2, I'm going to write my little brackets, negative 9, box them in, subtract 12 is equal to 6 plus 4 times negative 9. There you go. So then 2 times negative 9 is 18. Subtract 12 is equal to 6 plus negative 36. So then this is going to be equal to 6 is equal to negative 30. So you can see that's something wrong here. Hold on a second. 2. So you can see from the previous one, this should have been negative 18, because positive 2 times negative 9 is negative 18. This should be negative 30. And finally, negative 30 is equal to negative 30. This is how you check it, because you basically just prove that the left side is equal to right side, because the left side is negative 30 is equal to the right side of negative 30. That means that it is right, because the left side and the right side are equal. It's very easy to make these careless mistakes or the simple mistakes. That's why you just gotta be very careful about these things. So hopefully this video helped you and also humored you in solving equations. So I'll see you next time.